Hey students, quite a few of you missed school yesterday, so I thought I would make a video to show you kind of what you missed out on. This is our notes from yesterday, or from 10:15. We talked about the Bohr diagram, so in your notebooks, please make sure you're putting this in your table of contents. I just highlighted it there, page 19, Bohr diagram, 10:15. Page 18 was the vocab, and you can grab that from somebody or you can grab it off campus. Okay, so jumping right in. Electrons, we're going to split our unit up into two parts. We're going to have electrons and we're going to have bonding. But we need to start with electrons because they're the ones that are involved in bonding. So if we start with a quick review of the atom, our quick history, if you remember Democritus was the first one to coin the term atoms. All right, he coined the term atoms. He did not actually come up with an atomic theory per se, he just coined the term atoms. Our next scientist on the list is John Dalton. John Dalton is the first one to come up with the atomic theory. So he discussed atomic theory, and he took it a little further. He talked about how atoms bond with each other and how they create specific proportions and so on. So that was kind of his contribution. He was the atomic theory. J.J. Thomson, if you remember, he discovered the electron. And he discovered the electron by using a cathode ray or cathode tube and shot beta particles through and saw how much it bent and realized that it was 1/2000th of a hydrogen atom, so he knew he was onto something. Ernest Rutherford discovered our nucleus. All right, and he did the gold foil experiment. All right, he shot alpha particles through gold foil. James Chadwick came a bit later, but he discovered the neutrons. And a scientist we skipped as we were going through these was Bohr. Niels Bohr actually gave us a model that we use today. It's kind of advanced, but we're going to take it just kind of a little bit at a time, and we're just going to take a little piece of it and use it as a model to make or draw atoms. And so what Bohr said was that electrons are in distinct energy levels outside the nucleus. So he gave us those orbits around the nucleus. So that was one thing we hadn't had up till that point. They weren't sure where the electrons were. They just knew that they were there. And the other thing that Bohr came up with is that he said the energy levels hold certain amounts of electrons. So our first energy level holds 2, our second holds 8, our third holds 18, fourth holds 32. But when we're drawing particles or when we're drawing Bohr diagrams, we're not going to go much past 3. So how we draw them is pretty simple. The first thing that we do is we find protons, neutrons, and electrons. This is just like that nuclide symbol that we did last unit. So we can find protons, neutrons, and electrons using our mass number or our atomic mass from there. We'll put our protons and neutrons in the center, which is our nucleus. And then we'll put our electrons in orbits around the nucleus based on these energy levels that we have up here. The other thing that we should note, kind of a note right here, is that we will never have more than 8 electrons in the valence shell. And our valence shell is our last shell of electrons. Alright, so we'll never have more than 8 in our outer energy level. Never. Okay? So our next step is we're going to draw a couple of these out. Our first one is carbon. So we're looking for draw Bohr diagrams for the following elements. And we're looking at carbon. So our first step we said was to find protons, neutrons, and electrons. So we've got protons here, neutrons, and electrons. So if we look at carbon on the periodic table, its atomic number is 6. So that means it has 6 protons and 6 electrons, because right now these are still equal. All right, so protons and electrons are still equal. We're still drawing neutral atoms, which means they have the same number of protons and neutrons, or protons and electrons. To find neutrons, we're going to take 12 minus 6, because our mass number is 12, and our neutrons then are also 6. So that was step 1. Find number of protons, neutrons, and electrons. That was our step right there. Our next step says we're going to put protons and neutrons in the center. So we're going to draw a circle here, and we're going to put our protons and neutrons in the center. We've got 6 protons. My circle is not quite big enough. And we've got 6 neutrons. Draw a circle after. There we go. Now we've got our circle of 6 protons, 6 neutrons. Okay, our third step says to put our electrons in orbits. We've already used purple, so let's go blue. Put electrons in orbits around the nucleus. So we're going to put our electrons in orbits around the nucleus based on these numbers right up here. Our first energy level can hold 2, our second can hold 8, and so on. So, go here. We're going to put 2 in our first energy level. See if that works. Okay. Oops. Okay, click off of that. And now we're going to put 1 electron there and 1 electron there. Anybody have a thought as to why I'm putting them opposite of each other? It's because electrons repel each other, so we're going to put them as far apart from each other as possible. So I've placed 2 of my 6, so I've got to keep going. So I draw another circle. This will be my second energy level. And now I need to place, I can place up to 8, but I'm going to put only 4 because there are only 4. And if we count, we have 6 total electrons. Right? 1, 2, 3, 4, right? And then 5, 6. And these 4 that I highlighted are valence electrons because they are in the outer shell. So the ones that are highlighted are our valence electrons. Make sense? Let's try another one. Okay. So this time we're doing sodium. If these numbers aren't given to us, this 23, we can also look up at the periodic table. And sodium on the periodic table is 22.9898, which rounds up to 23. So its mass number is 23. So if we look at our protons, again, we use this right on the periodic table. Its atomic number is 11. So that means my electrons are also 11. And my neutrons, I'm going to take 23 minus 11, and I have 12 neutrons. So, going back, we draw a little circle. We've got 11 protons, 12 neutrons. That's in the center. That's our first circle. That's our nucleus. Okay. Now we're ready to put our electrons in there. Whoa, don't want to move that guy. Click off of him. Alright. Remember, we can put 2 in the first circle. Alright. Now we go to our second circle. This time we can put up to 8. And we're going to need all 8. Sorry, I didn't make a very good circle. We're going to need all 8. So, there's our circle, right? So we'll go 1 here. We put them opposite of each other. Now, what to do if they're opposite of each other? If you remember in our POGL that we did last week, we can partner them up because they'll have opposite spins, and we'll talk more about that when we talk about electron configurations. But if we look at that, I've now placed 10 electrons. If we go real kind of small here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You do not have to number them like this, just we're keeping track. And so our last energy level, we're trying to place 11, so we need a last energy level. Click off there. And there's our 11th one. If I were to ask you to identify which one is a valence electron, you would say that one. That is a valence electron. So, sodium only has one valence electron. Alright? Makes sense? Questions? Come ask. Thanks.